Hello, everyone, and welcome to the first video in a series on how to turn Bitcoin miner into a hot water heater. My friend Brian Gruneberg and I will be interviewing our friend slash hacker extraordinaire, Michael Schmid, aka @Schnitzel on all the socials, who has actually built one of these in his house. This will be the first video that will be an overview of this project, starting with the genesis idea of what happened inside Michael's brain to get us here, followed by a working demo of the existing system, and then some Q&A from Brian and me just to follow things up. Guys, is there anything that you want to add to this before we get started?
Hey, no, it's just super cool to be here. I'm actually keen to try build one of these. I've just moved into a new flat here in Mexico City, so everything's empty, and I think I've got some time and space to convince my wife that this is a good and interesting project to work on. So I'm super keen. It's really cool that this is available, and that Michael's sharing all of this stuff on the Twitters. That's where I first saw it, on your Twitter thread, Michael. And yeah, so just super keen, just super excited to be here.
Yeah, from my side, I love open source. I've been in open source since a long time. And now we're doing open source hardware. That's even cooler. So yeah, I love to share, to answer all the questions that people might have, and really help everybody to be able to build one of these at home and get paid to shower.
and why is that important to you? Why is open source so important to you? And why do you want, in particular, this project to be out there free for the world?
So for me, Bitcoin, as the code itself, is open source, and there's no single person that can control it. So it has the whole open source ethos in it. And I really think that projects like that should also be open source, because it allows everybody and anybody in the world, no matter where they are, to build one of these. Because I really think that there is an opportunity for all of us to actually make some money with all the electricity we're using every single day to heat our water. And from a more deeper level, I really think that Bitcoin is the money for the people. And so having miners running at home will also make sure that the Bitcoin network is secured by the people. And so that's a good solution to have your own miner at home if you heat your water with it.
Excellent, excellent. Short disclaimer for everyone watching. Actually, Michael and Brian and I, we actually go way back from the open source world. We've all worked in the technology sector together on particular open source projects. So this is something that's kind of near and dear to all of us, both the open source, I would say, ethos, as well as we're also all big Bitcoin nerds. And I think that we're our only friends. Okay, that might not be true, but anyhow. All right, so let's go ahead and get started. I don't know. Yeah, we said we were going to start with the genesis. So Michael, tell us, what happened inside your brain? How did this all start to come to fruition?
Yeah. So I've heard of Bitcoin probably like in 2011, and at that point you actually had to mine with your computer. That was the only way. So you had your notebook and it ran a bit hotter than usual, and you mined some Bitcoin. And then I got a bit disconnected from Bitcoin for multiple reasons. But then a couple of years ago, I think it's 2 years now, I came back into the space and I saw all these ASICs existing. And I was super interested in them, basically because mining with your own computer at home is not viable at all anymore, because we have this specialized miners that are called ASICs. And these ASICs are way more efficient in mining, but they're only made for mining. So they can only mine for specifically Bitcoin. And so, yeah, I was just interested in them. And so I felt like, hey, I want to buy one. I want to see how they work. And I got one and realized quite fast, actually, that they're super loud, but also that they produce a lot of heat. I knew like 1,600 watts. I roughly knew what that meant, but actually seeing it in front of you, blowing really warm, hot air into your face, yeah, I was a bit surprised how hot this thing is, because usually in all the computers, usually things get quieter and less hot, like specifically if you look like your phones or your computer, but that was the total opposite. It was brutally hot. I'm working in a garage apartment that actually doesn't have any heating, and I'm living at the East Coast of the US, and so you actually have to heat and cool the garage so that it's actually comfortable in working in it. And so I felt like, hey, could I use this miner to heat my garage? Because at that time it was like winter, and so I had a little space heater, and I felt like, okay, could I do that? And so, but I had to solve the sound issue, because yes, it was super, super loud. And so my very, very first version actually looked like that, where you can see, so this is an S9 miner that is sitting here. There's a power supply. And these are the normal fans that are super loud. Like we're talking about like 85, 90 decibel. So it sounds like a jet taking off in your garage. And I felt like, hey, this could maybe be something different. And so I got one of these squirrel fans that are much bigger. And because they're bigger and work slightly different than a normal, these like PC computer fans that we all know, it's way quieter. So I was actually able to whiff that a bit away from me to run that and actually heat the garage. So that was the very, very first version. Super elementary. You see there's some tuck tape there to make sure that it's not falling apart. But that was like the very first that I realized, hey, I can heat my garage and mine Bitcoin at the same time. From that on, my wife and I, we actually own an Airstream trailer. So that's a travel trailer. And we were planning to go for 6 weeks into Colorado in the US in vacation. And one of the issues that we always have is we heat the Airstream with propane. Now, for anybody that ever had an RV, they know that RVs are not very good insulated, and you don't have a lot of propane with you. So what ends up happening is that the propane heater is actually running a lot. Plus also, you have to refill that propane heater quite often.
Like how much propane are you using in a day to heat your Airstream in Colorado?
So if it's like below zero, so we're talking like minus 10 degrees Celsius Fahrenheit, we have a normal propane tank that is like you use for the gas grill. That is like, right. I think it's 4 gallons that is in it. And we had to get a new one probably every second day. We have 2 of them. So you can go for 3 to 4 days. But if you do this, it could happen that in the middle of the night, the propane runs out, and then you're gonna, it's gonna be very fast, very cold in the Airstream. So this was actually something that, yeah, we had to really figure out. And so that was the first thing that I felt like, hey, could I maybe use that miner that I have in the garage? Could I maybe also use this for my Airstream? But I knew I cannot run the thing inside the Airstream because it's definitely too loud. Like in the garage, I was able to put it like in a corner and like build a small like fence with like some cardboard boxes to make it less loud. But I knew putting it in the Airstream, yeah, that won't really work. And so I played a lot with this and came up with the idea to maybe actually put it outside. So that was the first. That's still at home. You can see there's cables everywhere, and like it's very rudimentary. There's like some cardboard that covers the regular propane heater. I had a multimeter to measure all the different, but that was like the first version that I felt like, hey, if I put this outside of the Airstream, still with the fan, in a box, and then just vent the exhaust of the miner into the Airstream, it actually goes into the normal propane heater, which sits behind there, because there's a fan that actually circulates the air in the whole Airstream. So I felt like, I'm just gonna try. So I did a couple of tests with that, and it seemed to work. The problem is it's never really that cold where I live, so we just had to go and see if it works. And to the happiness of myself, it actually worked out.
to yourself, I'm sure. Probably much to your wife as well.
Yeah, I mean, she was basically like, what's happening? And I was like, look, we're gonna just heat the house with this box outside. I mean, we've been together for many years that she knows that I have crazy ideas, and some of them work, some of them don't. But I think she also knows that she just has to tag along because I'm going to do it anyway. So, but no, what I'm actually specifically was very happy about that is if you look here, there's actually snow on top of the box. So that actually means that the air, because it heated the airstream, that the box itself didn't actually radiate a lot of heat, and most of the heat actually went inside the airstream. So how this works here is that there is a little inlet. So this white piece here, there's actually an opening. So it sucks in cold air from the outside. It heats it up through the miner. We can actually look at this here. It looks a bit better. So there is the exhaust of the miner goes through the box. So there's a hole in the box, and it goes through that piping into the airstream. And that's how it looks like inside. So you see that's the squirrel fan again. That's the miner. So that's where all the heat gets produced. That's the power supply. That one gets a little bit warm, but that's fine. And then I actually had a small Ethernet to Wi-Fi connector because the Airstream has Wi-Fi, but the miner has regular Ethernet and doesn't have Wi-Fi. So I had to figure out a way that. But yeah, that was the first night that we were somewhere that it actually snowed, and I was super happy to see that the snow didn't melt, meaning that we actually don't lose a lot of energy to the outside, and most of it goes into the Airstream. And after 1 week, yeah, the result was that we used 50% less propane. It didn't completely remove all the propane usage, just because one S9 is only 1,500 watts. And even though that ran all the time, because it was quite cold, like I said, it was minus 10 degrees Celsius Fahrenheit. So that it's still a lot of heat lost to the outside because the Airstream is just not that good insulated. But it reduced our propane usage quite drastically. And yeah, there should actually be space to add a second S9 in that system. So that maybe for next year, we can actually build a system that can completely, that the S9 can be run completely by the miners.
Wow. Did you actually successfully solve any blocks using the system, or did you get any rewards, mining rewards?
It wasn't a lot, but the plan at that point was really more to reduce the amount of propane that we use, because you see there's a power cord. So pretty much every RV place that you go has power. Some of them you actually don't pay for the power itself that you use. You just pay a fee per day to use the RV place, and how much energy you use doesn't really matter. So and yeah, it was a couple of dollar cents that we made. I mean, it wasn't a lot, but the most important thing is that I didn't have to think about every 2 days to figure out where to get propane, because in some places getting propane is actually quite hard. And you see other people having whole arrays of propane tanks outside so that they can only go once and fill up. So that was the most reason. But yes, totally. We found or my pool that I was sending my hash rate to definitely found some blocks.
Great, that's cool. And so from this whole Airstream, you know, where was the great leap from this to the hot water heater?
So this was all in winter 21, 2022 in the Northern Hemisphere. And as summer came, I was like, I don't really need to heat my garage anymore, and also not the Airstream. Right now it's just sitting in our driveway and it's not doing much. So I was like, how could I still use the miner to use the heat? And it came to me at one point after looking at YouTube and reading Twitter and just researching a couple of bit that the water heater at home actually uses heat every single day to heat the water, because we all like to shower, we like our clothes to be washed, we like our dishes to be clean, and they all need hot water. So, and that doesn't matter. The outside temperature, you're always gonna heat up the water in some way or another. So I felt like, hey, this could be the next level. That's something that can run all the time, is trying to use the miner to heat the water inside the water heater and basically replace that. And the more that I looked at everything, it also came to me that a water heater basically just just converts electricity into heat, and the miner does exactly the same. So if we shortly do a physics lesson, any computer generates 100% of the electricity that is used is converted into heat. So the computation itself is not really actually energy, or it doesn't go into a higher energy state or anything. So if you have a miner that uses 1,600 watts to generate all these hashes, outside of that miner is going to be 1,600 watt of heat. And your water heater, if you have an electrical water heater, does the exact same. It uses, let's say, 4,000 watts, converts this 4,000 watts of electricity into 4,000 watts of heat, and heats the water with it. So my idea was, wouldn't it be possible to use the miner to convert the same amount of energy that is used to heat the water, and in the end, actually have the same electricity bill than we also have for the water heater.
I love that you took the short intro into physics. What is that, like the second law of thermodynamics or something? Conservation of energy?
Correct.
Well
Yes.
done.
Yes, but the thing is, and honestly, like I wasn't aware of this myself, that it converts everything into heat. Like I always thought like, okay, no, they're like, these kids can only be like, or it goes somewhere else because the computer did some work, you know, like, isn't that actually energy as well? And it's just not. Like, it's 100% heat. And when I realized that, and the fact that I could use the same amount of energy that is used like the water heater. So my electrical bill that I, in the end, pay to my electrical grid company is going to stay exactly the same if I use the same amount of water. That's when the light bulb went off, and it's like, hey, there is something. Because for home miners, a lot of times it's either very, very hard to actually be profitable with mining, because probably we're going to talk about this a bit later, but different miners have different efficiencies. And usually as house owners or even apartment users, we have not very good electrical rates. They're stable, which makes it good, but they're on the higher side. And so actually be profitable for a home miner is quite hard. But the fact that I'm now replacing the electrical usage of the water heater just by the miner, and I'm going to use the exact same amount of energy, this whole, am I profitable or not, is not a question anymore, because I would have spent the electricity anyway. Yeah.
Yeah, that's just brilliant, right? It's where theory meets reality, right? You're just, I don't know, it's super cool, super cool. So has it actually worked out that way? Are you having, is the efficiency the same, or do we want to come back to that?
I think we can go back to it specifically, but yes, as a spoiler, yes, the efficiency is almost the same. It's a little bit less, but no, it is totally the exact same, because physics works. Who knew?
Okay, to connect it somewhat to our shared passion for open source, there's a fringe benefit, which is by doing this, you're keeping the computation that's required to keep the Bitcoin network decentralized. You're contributing to that essentially, it's not costing you anything to contribute to the freedom of the decentralized, at least freedoms from the decentralized nature of the Bitcoin infrastructure. So that's kind of cool fringe benefits.
Yeah, for sure. For sure. Well, this is fascinating. Does this work with any type of hot water heater, or you have any other, what other type of hot water heaters could this be built with?
Yeah, so let's actually look at how a water heater works. So what you see here is a diagram of the two main water heaters you will find probably in the world. I can speak about North America, but I know also other places it's very similar. That's either an electrical water heater, which is on the left side, or a gas/propane water heater on the right side. So if we look at the left one, we have a tank, which is very well isolated. And inside we have 1 or 2 or 3 different types of heating elements. And if you look at these heating elements, if you have ever looked at a water cooker, like to make tea, it's basically what this is, just a bit bigger. So you have heating elements that basically heat up the water that is inside. The cold water comes in through one of the pipes. The cold water gets actually dispersed at the bottom of the tank, where then these electrical heating elements heat up the water and it rises. And on top here, you have the hot water that gets pulled out. The gas one is similar, just instead of having these electrical heating elements, you have a gas burner at the bottom, and you have this vent in the middle where the hot air, so it heats up air, and it's basically just the same that if you have a gas oven or a gas stove, you put on a kettle with water in and it just heats it up. The exhaust goes on top out. The cold water comes through here, also gets dispersed at the bottom, and the hot air, the hot water also comes out on the top. Now, one of the things that is important is there's no pump for pressure or anything. So the pressure actually comes from the cold water. So the cold water that is usually connected to your city, municipality, whatever, that's the water pressure that goes in that actually provides the water pressure for the hot water. So if I open up my shower and open up the hot water, the pressure of the cold water is actually going to push out the hot water. And when we look later of how the whole system works, we're going to see that's important. But basically, the hot water is just going to push out. And all there is here, there are a couple of thermostats with the heater element, and the same also in the gas, that measure the temperature of the water, because as new cold water comes in, when you when you use the shower, the water is going to cool down automatically because it can mix the water. The thermostat will realize that there's cold water, and it will turn on. And it will turn on until the thermostat measures that it's hot again, and that's it. So the functionality is very, very, very simple. There's actually no electronics involved in all of it. The thermostat are just bimetals that just flip a contact based on the temperature. Yeah. So it's very simple, but very efficient, and actually super, super easy when you understand of how it works. And that makes it super easy to hack, which we did.
It's a mechanical analog system, right? It's either on or it's off.
Correct. Yes, it's there's not much, and that's actually one thing that it took me quite some time to understand that is not that complicated, because I really thought like there has to be a little computer and a microcontroller and maybe even a pump. But no, there's literally just like 2 pipes and that's it. Like that's the whole thing. So
yeah.
So cool. Awesome.
Yeah, super cool. I mean, definitely don't want to derail the conversation, but I'm like, oh yeah, that made me think about, a thermocline when you're scuba diving, and there's the temperature differentials in the different parts of the water, and but seeing how basic that is, that's a great explanation. Thanks for walking us through that.
Of course. And so yeah, that was basically. After I understood that, I felt more comfortable in actually doing this. So I started looking around. I found a couple of other YouTubers. I found a couple of Twitter people that did this as well. I actually found a lot of people that they use some kind of other augmented system. So for example, if you have a lot of wood, you can use like a wood fire oven to use that to heat the water and parts like that. So I basically took all this different like knowledge together and came up basically with the idea of creating our water heater. So so that's what we currently just looked like, just is in a schematic. So we have our water heater. Inside, there's either an electrical or a gas burner. It really doesn't matter. It works with both, and we're going to shut it off anyway, so we don't care. So we're just going to use the water heater just for its storage capacity. But basically, you have the municipal water that is cold, and you have the hot water to the house, to your shower or whatever you use it for. And so what I thought about is, how can we now use the miner? Now, the first thing is, all the miners that you can currently buy, they're all, let's say 95% right now, they're all made to be cooled by air. Meaning, if you want to heat up a water, you need somehow transfer the heat into water. Now, the miners, they don't like water at all. They're like any other computer. If you put them into water, you can create a short circuit pretty fast, and then your miner is gone. So
is that from experience? Did you try that first, or did you?
Actually, I have a bit of history of water cooling computers, and I had a couple of leaks. And yes, sure. I had a burning graphic card because the water, like the CPU cooler leaked and dropped water on top of the graphic cards. And I was still in school, and burning like a $200 graphic card was a bad idea. So yes, I've not with miners, but I had experience with that. So basically, we need to find a way how to get the heat from the miner into the water. And how I do this, and how this is currently the best way right now, is to use a liquid that is not electrical, that does not let electrical current to flow. And that is an oil. Most of the time, there's other ways, but what I'm using a system or an oil called BitCool. That's of a company specifically. They make specific oils, or they call it a fluid, for cooling. They started to cool servers, because if you have really big data centers, you can also cool your servers with it. And they have a product called BitCool, which is specifically done for miners. Because the reason is, you cannot use just any oil, because a miner has a lot of different materials in it. So there's some plastics, there is some metals, there is some compounds and other things, and you need to make sure that the oil doesn't react with them, because some oils react with stuff. So some people just use mineral oil, that works, but I've heard that like over time the miner actually some components on the PCBs of the miners, they actually start to blow up because they suck in the oil and stuff like that. So
sure.
So I'm using BitCool, and what happens is, so these S9s, they are inside a fish tank, and they are immersed completely in that oil. There's a pump that sucks the hot oil into this heat exchanger that I'm going to shortly explain afterwards. And then the BitCool flows back below these miners, and that's basically the BitCool loop. So there's a separate loop that only the oil has. And we see that we put this plate exchanger in between also the water that comes from the municipal water that heats up then the water that goes into the tank. So, and this plate exchanger, and we will see it afterwards if I show you, but it's basically a lot of plates, and it allows these two fluids to connect but never touch. So the hot the hot BitCool that comes here from the bottom, because the water is cooler, by physics again, there's no need to do anything. Just because you have a cool and a hot liquid, if you put them really close together, they will start to, the hot liquid will give its energy to the cool liquid, because they always want to have an equilibrium. And so just because of that, the water that flows through this will be heated up fully automatically, and the BitCool will be cooled down fully automatically. And so that's basically how the whole system works. The BitCool will be hot, the water is cool, and it will switch. And so the BitCool that comes out of here is cooler, will be heated up by the miners again, and that's basically the whole system.
So, all right, so you explained the BitCool, and that's basically this sort of specialized oil that doesn't conduct electricity. Do you need to do anything to the miner to prepare it, or you just take your miner and drop it straight in?
It depends a bit on the miner. The big question is about, do you still keep the fans or not? There's actually different ways. We will see later. I'm currently having still one fan of it, still existing, just because it brings the bit cool a bit faster through the miner, so it creates a bit more exchange. Also, the S9s that I'm using, their power supply, they actually couldn't keep up with the heat that the miner generates, so they're actually outside. And we will see this later as well. Some miners, the power supplies are now integrated, so you can leave them in there. But technically, no, you don't need to do anything to the miner. The only thing that I usually do, because when you buy the miners, they usually ran for a couple of years in an air environment, so they're very, very dirty. So you clean them with the BitCool itself, actually. So you just brush them off to get off. Because what is a danger is that could happen is that, let's say you have a shaving of a metal or something that then gets into the BitCool, that then could, because it's now transferring through the whole system, it could actually touch a piece of the PCB, then create a short. So you want to make sure that like all the dust and stuff is off, but that's it. Like you don't have to modify the miners in a specific way. You just, you just put them in.
What you call the heat exchanger, right? Is that, am I using
Yes.
the right word? Is that just something that is kind of an off-the-shelf, kind of commercially available component that you bought, or is this something you had to build? Or
no, you can buy them. So in any systems where you have two liquids and you want to exchange the heat of them, you will find these pieces. So yes, you can buy them. It's not something you find like in the US, like in Home Depot and Lowe's. It's not that widely available, but you can find them online. There's different companies that sell them. You can even find them on Amazon. So so like, for example, if you have, like what I talked about, the wood firing stuff, they use them as well. And if you go into industrial things, so like data centers and stuff, they have massive versions of them. Because yes, you can have two liquids. So sometimes like the liquid that you actually use to move around, you don't want this to be water, but outside you want to have water. So yeah, this is like a common thing you will find. So it's not something I had to build or weld or anything. So one thing though that we haven't talked about this yet is that this system would actually only heat the water when you use water. Because so the heat or the water that comes, the cold water that comes in here only passes through the plate exchanger or the heat exchanger when somebody's taking a shower. Now, one thing we have to understand of heat exchanging, this needs time. So if the water that if the BitCool that comes in here, let's say is 60 degrees Celsius or 140 Fahrenheit, and the water is like 20 or 30 degrees colder, you cannot even that while the water flows through. Like it's not possible. So the water that passes through, even though that the BitCool is maybe 20, 30 degrees hotter, the water that passes through is only going to get heated up by a couple of degrees, if even. So that means, or, I mean, it's possible, but then you have a massively big plate exchanger. Like if the water takes 10 minutes to flow through the whole thing, yes, then it's maybe possible, but these plate exchangers, they're quite small and the water passes through very fast. There's not enough time to actually pass the energy over. That's again, just a physics thing. So what I actually built is also a water loop. So additionally, what I'm doing is the tank, the water tank, usually, or most of them, they have a flush valves at the bottom. So you can flush them over time because you actually have sediments that over time start to fill at the bottom. And so I'm using that drain valve to pump the water that is at the bottom. Again, that's the colder water. I pump it out of the tank and back into the top where it came from. So to create a second loop. So this loop is basically then taking the water, let's say the water comes in of normal outside air temperature. That's usually what the water comes in. It heats up by a couple of degrees, but it's never yet at the temperature that you need for a shower. It goes into the water tank. It mixes with the water tank there, the temperature gets pulled out again and gets put in at the top again. So it will over time take the water out and slowly over time together with the miner heat up the water that is in the tank. And as soon as the water in the tank is hot enough, in my case now, 140 degrees Fahrenheit, that's 60 degrees Celsius, the whole system will shut off because you don't want to get the water much hotter because it doesn't really make sense to make the water hotter. Because A, you're not going to take a shower that is 60 degrees anyway, like you will burn yourself. So it's a safety risk. But also you never want to get the water to boiling because then you suddenly have a steam engine and you don't want a steam engine in your house either. So you need to shut off the whole thing. And most water heaters, they heat up the water to 140 Fahrenheit, 60 degrees Celsius. So there's also a little temperature thingy here. We're going to see this later on my system that tells a little computer to shut off when it's hot enough. And this will then tell the miners to shut off. So that's maybe another thing. This system doesn't run 24/7. This system only runs for when it's actually needed. So every time that somebody takes a shower, right after it is running, or also over time, because over time the water in the boiler or in the tank actually gets cooler. So you're going to have to reheat it from time to time. But that's all that temperature sensor does. But yes, with this system, you can completely disconnect the normal water heater or your propane system, and the miners will keep the water at 140 degrees all the time.
Fascinating, fascinating. Sorry, go ahead, Brian.
No worries. When it shuts off the miners, are you shutting them down, or are they still running, just not processing, not kind of chunking things?
It depends again on the miners. The simplest would be to just have a relay at them and just cut them from the energy source. The problem is then that if you turn them on again, they usually have a boot process and things like that.
That's what I was wondering.
What I actually did, so we can maybe look at this a bit later as well, but most of the miners have an API. And so you can actually tell the miners not only to turn on and off completely, you can actually also tweak how much energy they use. Because there's a couple of thinkings there that, like, if they run a little bit with less power, they're actually more efficient. So there is a couple of things there that you can do. So no, the miners are running all the time. They're just paused. They don't do anything. They just sit there and wait for jumping into action again.
And I guess the electrical pull on them just sitting there is probably minimal. It's negligible.
It's a couple of watt hours, so not something that costs you a lot. No.
Yeah. Cool.
Yeah, it's kind of like leaving your computer on standby or sleep mode, right?
Yes, totally. Yeah, it's not going to be much.
Yeah. Well, that's great. I don't know. I think you were planning to actually show us this. I mean, this has been a great overview and everything, but
yeah, you want to see it?
Can we see the thing in the wilderness?
All right. Yes. Let me go over there. I will be right back, and I can show you the whole system.
And here we are after a quick wardrobe change. I mean, geolocation change. All right, Schnitzel, what are we looking at? Take us through it.
All right, so basically that's what we saw before on the schema, now live in action. I guess I will shortly show you each piece overall, and then you can ask all kind of questions. So obviously the piece that we see right here, which is the most obvious one, this is the S9 miner running in there. If we look from the top, you can see that's what we saw before on the picture from the Airstream. And it is completely submerged in BitCool. So you can see the BitCool comes from the bottom here. It comes through this pipe. The fan is still running. It helps to push the BitCool a bit faster through this enclosure. What is actually really good about these S9s, they have this shape, this square shape. So it pushes the BitCool through that.
and it comes out. You could totally run it without the fan, and I've done this before. It works. It just it takes overheat a little bit better, but not necessary at all.
It's like a boat propeller, right? It's just
correct.
Helping
a little bit, yes. One important thing is though, not every fan can actually handle it, because there's way more resistance to the fan. So some fans, they actually just stall and stop. So it's a little bit of try and error, because there's different types of fans. And then, so what I've done to this is a normal fish tank that you can buy at any Walmart or any store. And what I've done is I put this additional piece of glass that separates the left and the right side, because you want the bit cool to flow over here, and it goes on this side. And you can see there is like bubbles and stuff coming. So this small part over here helps the bit cool to calm down again, and it gets sucked out of these two PVC pipes here. It gets sucked out again. Yeah, so that's the whole thing. Clever viewers will also see that there's more space here, and I could also move that glass further out. So I've built a whole system that it's expandable, because I want to play with different miners, sizes, and stuff like that. But yeah, basically that's the miner is all in there. It's made for that. So usually it actually, what is important is that you blow or you push the bit cool the same way as the air would go through as well. So it usually goes from the same way that it's set up now. It's also where the air usually would push through. And then we see that's all the cables. So that's the cable. And back there, if we look here, there is the power supply for it. So for S9 specifically, the power supplies, they cannot actually keep heat that good as the miner itself can. So they would shut off if we put them into the bit cool itself, because it's just too hot for them.
How hot is the bit cool right now?
So right now I have a temperature sensor here. It's 146 Fahrenheit.
Wow.
Which, let me actually move the sensor a little bit over right there. We'll see, maybe it goes up a bit. So in the current state, how it is no, the water heater is fully hot. So it's all filled up with 140 degrees water. And I just let the bit cool running all the time. Usually the whole system is completely insulated. So I have here, so this usually sits there as well. So there is insulation all over and also on the top. And we can see it's insulated on the right side and also over there. So you want to make sure that you don't lose, because you would lose heat to the room. Like the bit cool, if it's opened like that left, it will heat up the room, and we don't want to heat up the room. We want to heat up the water in there. All right, so the water then gets sucked in, goes through this pipe up and over here and goes into that red one. It could, of course, be easier to just drill a hole in glass, but I don't have any of the tools that are necessary, so I had to go a little bit over it. And we can also see this piece here. That's to fill it when you want to fill the whole system, and also to empty it again, because it actually has to suck oil up here. So that's it needs to overcome that height a little bit. And if it's full of bit cool already filled with that one, it's much easier. The bit cool then goes on the right side, goes down here and runs under here, comes through, and there is the pump. So I took off that insulation for now so we can see it. So this is a regular hot water system pump, a so-called circulation pump, that is used for hot water systems in your house. If you, for example, if you don't have enough water pressure, a pump like that is used, or also for floor radiation heating. They are made to become very hot. So you can see on the temperature there, they can go up to 240 Fahrenheit. So that's no problem at all.
That's how hot the unit will actually become, or that's how much it can handle to
That's how much it can handle, yes. Yeah, you want the pump that can handle the bit cool, like the 140 degrees.
Yeah. So why do you have that insulated? Is that getting really hot as well?
Yes, yeah, it's pretty hot. It's hot to like I cannot touch it for more than like 2 seconds because it's really, really hot. So you could fry an egg on there. Then for anybody that builds this, always add a drain plug at the lowest point, because you will at one point need to drain the whole system. So that's something I didn't do at the beginning, and that was a lot of fun because yeah, you maybe need to drain it at one point. So there's a drain plug, so I can put a bucket down there and I can just open it up and all the bit cool comes out. And the hot bit cool comes then from the back here and goes through here and goes in here. Now in here, I'll remove this a bit so we can see that is the plate heat exchanger that we saw from before. So these are the individual plates. They are pressed together and welded together. And through each of them, so the odd numbers, or let's say water, and the even numbers are bit cool. I don't know what exactly it is, but basically the bit cool, the hot bit cool comes in here, flows through that whole thing, and comes out at the back here again. So, and we can see, so I, like you said at the beginning, we're all nerds, so I went full on nerd, and I actually have temperature sensors everywhere, so we can see them. Well, they're inside the insulation, but you see these screens. So right now, the bit cool that goes into that plate exchanger is 143 Fahrenheit. That's for the non-imperials, that's around 50 degrees. No, sorry, around 60 degrees that goes in. And on top out, it comes again with 144. Now, the temperature sensors are not perfect and they're not perfectly placed all the time. So there you always have a little bit of discrepancies. So right now it's actually cooler going than it goes out, but maybe we can talk about the system in the end. There's some improvements there I could do, but in the end, so like I said, it doesn't actually heat up water though. So it just keeps the same temperature. It comes out here. There's a flow sensor as well behind there. So I can actually measure the flow rate. Right now it's 14 liters per minute. And there's also a system that you can play with. It's like how fast the individual fluids are going. Then the heat exchange is slightly different. But right now I just run them on the hottest setting. It then goes behind this pipe here, goes through here, goes at the bottom again, and gets dispersed through that pipes and comes out of these little holes that I made. Goes through the water to the miner again, and that's the whole bit cool loop side of the whole thing. Like I said, it runs all the time for the simple reason that because if I turn the pump off, these two fluids would actually equilibrate themselves. And so then the miner will be partially not in the water or not in bit cool anymore, which could be quite dangerous if you then turn on the miner again and the pump is not running yet. So that's why I run them all the time. There is a solution to that. If I would fill up the left side as well to the same level or almost the same level, I could shut it off again. But right now, that's what it is. There's definitely improvements because right now the pump is running, even though it's technically not necessary because the miner is not running. You can see it's the control panel is running, but it's not actually using energy because the system told it to not run.
Does the bit cool act as a kind of noise dampener? I guess you can't hear the fan when it's running.
Yes.
Full tilt, right?
Yes. So the fan, I mean, the fan is running only with like 300 RPM. Usually it runs like at 4,000 or 5,000 RPMs. But yeah, if you take it out, it's very, very loud. So because it's running slower, but also it's in the water or in the bit cool, sorry, it's dampened a bit. Yes.
Cool.
Cool. So let's look at the water side. So in my system, this is where the cold water comes from the municipality. It goes in here, and usually it would go into the water heater. Here is the cold inlet. Now, what it does, it first goes through the heat exchanger, the plate exchanger goes through here, and then goes into the water tank. Like I said, there is a rod inside the water tank. Inside of it, you can see that. that goes all the way inside and actually disperses the water at the bottom here. Then usually the water sits just in it. And we have here the two access points to the thermostats and the heaters. So the heaters are running here and here in the background. And then on the other side, we have the hot exhaust that comes out of here and then goes back there. And that's basically going to the house, to the showers, to the dishwasher and all the stuff. Yes, there's also this pipe. Some people maybe want to know. So this pipe is just an exhaust. There is a safety valve here. If the water in here would get hotter than, I don't actually know what it says, more than 210 Fahrenheit, so just below boiling temperature and 150 PSI, it would actually open up. So that's a safety valve if you make the water too hot. For any reason, this would open, but it doesn't go anywhere. It just goes at the bottom. It's just a safety thing. And
so
then
do you just, oh, sorry, go ahead.
And then, so the other piece that we saw that I explained on the schema, so this is usually the drain plug. Usually nothing is connected here ever, and it's closed. In my case, it's open, and it goes from here to behind this wooden piece, and there's another pump. This pump takes water from the bottom of the water heater and pushes it up through here, goes all the way to the top, and basically connects again, like we saw before, where also the water comes from the municipality and goes back through the plate exchanger. Now, this pump is currently not running. This pump is only running when actually the miner is also running, because it's just not necessary to circulate the water. It's really not needed.
All right, I'm going to throw you a curveball here, Michael.
Yes.
Looking at this, what's the contingency plan? What if something broke? Could you convert this back? Is this a permanent solution? What are your thoughts on that?
Yeah, so let's actually look at how this is converted. So if we open this up here, so this is the access panel to the two thermostats, and there is one here as well. Let's actually look at the lower one because they are a little bit easier. So you see that's insulation. So the whole thing is actually very highly insulated. It's like 3-4 centimeters of insulation. And back here we have the thermostats. So if I remove this here, so this is the thermostat. This touches the back. So behind there is the wall of the water heater. It's super hot. I can't touch it. It's too hot. And there is what I explained before. There's the bimetal piece, and in there, this metal either makes contact or not, if it's hot enough or not. There is also a setting here. You can switch this, so you could actually change the temperature. And usually there is these two connectors here, and usually they are connected directly to 240 volts mains power supply or power from your house. Again, it's 240 and not just 120. So it's high voltage, but I removed it all and it's actually disconnected in the breaker panel, and it goes to this piece here. So that's the rod of the water heater, or the actual electrical heater that pushes into the water tank where the water touches. And this is connected. So you see here right now, it's not connected. Usually this will be connected. And yeah, so to your question, if I want to build everything back, all I would need to do is remove this cable here. I'll shortly explain what this does afterwards. I would just push this all back in, flip the breaker on again, and that's it. And there's even a system that I actually also mounted. I'm not sure if you can see that there. There's a temperature sensor as well here. So I'm measuring actually the water that is in there as well. Again, that's all not needed. That's just because I'm just interested in it. But technically, I could also actually let the electrical system always connected and maybe just set the temperature a little bit lower than what I want, so that the electrical system would jump in if the miner, let's say for any reason, is unable to heat the water. So
you have a failover.
Correct, yes. And also important is I'm not warranting, or now I'm not voiding the warranty of the system in any way, because all I do is I disconnect the electrical system. I'm not changing the water heater in any way that that I could lose the warranty of it. So even if I ever want to sell this or whatever, I just put it back, and it's all gonna work again as it did before. Yes.
Cool.
So yeah, so I'm actually using these temperature sensors or these sensors. There is a cable here connected to thermostat. The same is also on top. So my water heater has 2 of them. And there's another one here. It's a bit more complex up here, doesn't matter, but basically it's also connected to these 2 there. And it's the same system. You have a setting again, and you have a heater. Bigger water heaters, bigger water tanks like this one have 2 heat elements just to heat the water a bit faster, especially if you use a lot of water. There's a lot of cold water on top, so it actually runs the one on top. In my case, yeah, I'm looking at which of the thermostat is running, and at any time I run the miners, because I don't use the electrical things anymore. But basically these white cables go back to this whole system back here, and goes into that is connected here. So that's the connection of the thermostat. And that goes into a small microcontroller that senses if there is a connection or not. And this then sends that data to this here. This is a Raspberry Pi that runs Home Assistant. And that Home Assistant is able to talk to the miner. So Home Assistant can talk the API of the miner. And whenever it senses that the thermostat is open or closed, it tells the miners, hey, please use or please run, go ahead and run the water or heat the water up.
So you're using the thermostat of the actual thermostat of the water heater to trigger whether the Bitcoin should be on or the miner should be on or off.
Correct. Yeah. So that's one way to run it. That's how I run it right now. Because I feel it's the simplest way. I mean, technically, even you could actually use that, and I haven't tested it yet, but that would technically be possible. You could connect here. You could connect the miner directly to this, because the miner is also 240 volts. So it would only run the miners when this thermostat. So you could actually go without any of the computer stuff that I have up there. You could just run the miner through that, and that's it. Like, it would be possible. It's all 240 volts. So
that's just yes. Cool. It's just a switch, right? That's right.
Correct. Yeah, it's just an electrical switch. Eventually, I'm probably going to switch back to the temperature sensor and switch based on temperature. But at the end, like I said, I'm just trying a lot of different things. And as it is configured right now, it actually uses that thermostat to decide if the miner should run or not.
Very cool.
Yeah, all these other things that you see here, so all the stuff at the bottom, that's just because I added all these temperature sensors. So if we, for example, go over here and pull this off a little bit, you can see there is a temperature sensor back there. I have temperature sensors and flow sensors at a lot of different places. Again, that's not needed for the actual system to work. It's just for me to gather a lot of data that we understand how the system works and behaves. Yeah, so that's, but all of this would technically not be necessary. Like I said, you could literally just use the normal thermostat. And on the right side, we have 120 volts. So this is all 12 volts and 5 volts. Here we have 120 volts, and this runs the pump. So this controls the pumps. There's one pump and the other. And so I can remotely start and stop the pumps again through the Raspberry Pi. So that thingy can tell the pumps to, or the relays to close, and then that turns on the pumps. So, yeah.
Wow. All right.
All right. So I think we should actually put it into usage. Now, I've configured the system right now that I actually have. So this pipe here is the outlet of the hot water, and I have a flow sensor there. So my system is currently configured that if there is, for more, I think 30 seconds, somebody uses hot water, I know that there's cold water rushing in, and I know that that sensor at one point will trip, will switch, because it's getting cold. But this takes a couple of seconds, maybe up to 2 or 3 minutes. So because of that, I'm actually measuring the flow here. And if somebody takes a shower and for a couple of seconds, it will tell the miner to turn on before that even the sensor down there switches. Now, again, this is just for a test, but it makes it a bit easier. So I will point this to there and I will go over here real short.
You're not going to go take a shower on us, are you?
No, I'm not going to take a shower. I'm just going to run the hot water real fast. So the hot water is now running and you can see the flow is running there as well. You can also see that the temperature, because the temperature sensor actually sits back there a bit. So it's not in the tank itself. So you see the temperature rises as well because there's hot water now rushing through that. And you can also see, interestingly, that so what happens now is the bit cool that comes in is 140 degrees, but it comes out as 170 degrees because we have cold water that now rushes through here, goes through the plate exchanger and comes out here. You see the water that comes out of it is 115 Fahrenheit. So the water that comes from the municipality gets heated up or is cold, comes here, gets heated up through the bit cool and goes into the water tank. And it drops right now because it just takes a bit. But what is interesting, the water that goes into the tank is 111 Fahrenheit. The water that comes out is 135 Fahrenheit. And that's possible because the water goes all the way down. So the cold water comes out here now. And the hot water that got pulled from here is not affected by it. That's the clever system of the water heater. Because if the water would be dispersed here, the cold water would go immediately down here and go out and you have a cold shower. So that would not be cool, of course. So yeah, I just actually got a notification. So the Home Assistant there now realized that the water flow was running for more than a couple of seconds. And he told the miner now to actually turn on. So the Home Assistant is connected to my phone and it actually has push notifications. So I just got a push notification that told me, hey, the miner is on. And I'm gonna now turn off the water because that was enough for the water to turn on. So I turned off the water. You see the flow is now at 0. And we see that the bit cool in the meantime drops to 118 Fahrenheit. If you remember, it was like 140 before. So it actually dropped quite considerably because the bit cool was still circulating and there's cold water that came through here that went into the system.
Right.
Now, while the miner is now running, the system realized that there is now cold water in here. So the temperature sensor down here now dropped and this one most probably also turned on. And now it actually turned on this pump as well. So it is now actively pulling cold water from the bottom, pushes it through here. And we can see there, this flow sensor is now running as well. So it shows 13 liters per minute. So, and you can see the temperature of the water that it's currently pulled from the bottom is 119 Fahrenheit. So at the bottom here, we're pulling out 119. That's that one. It goes in here into the plate exchanger and it comes out of here with 121 Fahrenheit. So the plate exchanger right now is heating up the water by roughly 2 degrees. Like I said before, it's not a lot. It's just a little bit. It gets pushed in, goes all the way to the bound, gets pulled up again. So this is now running in here. So 121 is it now in, 123 now out. So this will now slowly rise. On the other side, we see the bit cool now heats up again. Before we were at 117, it's 125 now. So you can see, if we zoom a bit closer, you can see a little bit how the hot air, or sorry, how the miner is now actively heating up. You can see the little bit like wavy things. You can see from that because the bit cool, the different temperatures have different viscosities, and that's what you see. So what is now happening, the miner is now running full power, heats up the bit cool. It's just a little bit hotter right now then the water, and it will do this until this temperature is around 140, which is the setting of that thermostat. So that thermostat will at one point will switch off again, because the water that is in there is now again 140. It will then tell the miner to stop, and it will also tell the pump to stop again. And that's basically at that point, it's gonna wait again until somebody uses water again.
That's great.
Super cool.
Yeah.
Are you
So-
streaming all of these? Sorry.
No, go for it.
Are you streaming all of the sensor information to something that's collecting this data the whole time?
Yes, yeah. So the Home Assistant that runs there is collecting all the sensors every 2 seconds. All the sensors are collected, and we can actually look at it afterwards. I can show you on the computer all the data. So I see the temperature sensors, I see the flow sensors, I see the sensors of the thermostats, I see if the pumps are running. I also see stats about the miner, so I know how hot they're running, how much terahash they're doing, all that stuff. Plus, one thing that I can't show you, but I'm actually also having watt sensors on my panel. So my electrical distribution panel has also sensors on that actually measure how much watts of electricity goes into the system. So I know exactly how much watts I used, because that's how I'm comparing the two systems.
Right. That's where you're figuring out, like, you know, basic questions start to come to mind of how much does it cost to run this? And also, you've already mentioned that a lot of these sensors and things, they're not necessary. This is probably part of your nature and the data collection and everything. So, you know, I think 2 follow-up questions here. It's just, you know, how much would it cost, maybe not to build this system, if you could, well, you could tell us that too, but I'm thinking more like a stripped down version for somebody that doesn't need all the data collection. And how much does it cost to run?
Yes, so the simplest way that I could imagine running this, you need a miner. Now, the price of the miner, I think we can shortly look at that afterwards, but the one I'm running right now is an Antminer S9. And they cost, with the Bitcoin price right now at around $20,000, they cost for like $200 to $300 US, which is quite cheap. They used to be at like 600 when we were at 60,000. So right now is a good time. If you're planning a system like that, do it now. It's a good time. So around $200 to $300 for that. Then the BitCool itself, that's probably not super cheap. You can buy it in 20 liters or 5-gallon buckets, and it costs around $200. Now you see my system, there's a lot of spare. It wouldn't be necessary in any way. So if you find a smaller tank, you wouldn't have that much waste, but I would say plan around 20 liters. So that's another $200. And then, of course, the fish tank, but that was $15. All the piping stuff, again, that's not super expensive. This is, by the way, this is normal pipes that you would have for any house thing. So this is CPVC, that's chlorinated PVC. You need that because normal PVC would actually get mellow in the temperature that we're running in it. But you can find this at any Home Depot, home store. The red pipe here is normal PEX. That's what you find everywhere in every house now for hot and cold water systems. The pumps, they are maybe like $80 each. You could find cheaper ones. The more expensive piece is, again, the plate exchanger. Now this one was like $90, $100. There's different sizes and stuff. But so if you count everything together that you need, so the miner, the BitCool, the tank, the PEX, and the plate exchanger, without any of the electrical stuff, without any of the sensors, without any of the fanciness, I would say right now you look at like $500-$600 of initial cost to set up the system like that.
Plus the miner, right?
No, that would include the miner. So $200 for the miner, around $200 for the BitCool, around $100 for that piece. Then the pumps and a couple of accelerators, yeah, around $600. All right, so while we talked, we can shortly look at the system as it is right now. So the BitCool has heated up to 134 Fahrenheit, so it grew another 10 degrees. The water that comes out of the at the bottom of the tank is 126 Fahrenheit and gets into the tank at 129 Fahrenheit. So we're already close to 140 again. And it will take a couple of more minutes. We don't have to wait for that, but basically at 140, everything will be shut off again. And yeah.
I guess you could probably build the system with any proof of work cryptocurrency if for some weird reason you decided that you didn't want to do Bitcoin, but is that right?
I mean, in the end, you can put whatever. I mean, you could put your computer in there and it would work as well. Like it really doesn't matter. I'm just using a miner and specifically a Bitcoin miner, but you could also use GPUs and things like that. The only thing, of course, is so maybe that's a question. So the BitCool, in order to heat the water to 140 degrees, the BitCool gets up to 150 degrees. So that's around 65, 70 degrees Celsius. And you need to have something that actually gets that hot. And actually the chips in there, so if you look into the miner, you see all these are the heat sinks. Again, they're usually made for air and they're not super efficient for oil, but that's what we have. And behind all of them, there are the chips, and the chips are actually getting up to 100 degrees Celsius, so 200 degrees Fahrenheit, 220 degrees Fahrenheit. So you need something that gets up that hot and can handle the heat. Like I said, the whole reason that the power supply is outside is that the power supply, the max temperature it can reach is like 60 degrees Celsius. So it would actually shut off before the miner would shut off. And so that's something. So you need to be a bit careful specifically if you use like computer and normal computers or like GPUs for like mining other things. It might not actually get that hot. It will shut off earlier. The miners, though, they are made for that hot temperature. So because of that, we can actually use a system like that.
And when you do get a mining reward, I imagine you're somehow trying to offset your electricity costs. Are you hodling? Does this go straight to a cold storage wallet? Are you putting it on exchange?
Right now, so I'm using a pool that gives me the Bitcoin, and I'm just sending it to a wallet of my own. And yeah, because the interesting piece about this is, and specifically right now, so July 2022, non-KYC Bitcoins are super of interest because everything else, like everywhere else that you buy Bitcoin, you get KYC'd. And so this is actually one of the very, very best way to get non-KYC Bitcoin, meaning nobody will know who mined or who owns this Bitcoin because you never had to give your name. The pool will send that to your wallet and there you can hold it. So yes, I have a specific non-KYC Bitcoin wallet where only the Bitcoin from that miner and the other miners I have are sent, because you never know when you need to do something that people don't need to know that you have Bitcoin or whatever. So, and yes, so for me, these Bitcoins are a bit more, not worth, but they're more worth to hodl because you never know when you need them.
They have more value to you.
Yes.
Yeah.
All right.
Excellent.
I guess I will go back, or unless you have more questions about the system itself.
No, I mean, I think, I'd probably have to watch this 4 or 5 times to digest enough information to come up with a smart question. So I think that's good for me for now.
Yep. All right.
All right. We'll see you in a few minutes.
All right. See you again.
All right. So here we are again, back with another location change. That was fascinating. That was really, really awesome. Thank you so much for walking us through that. It was pretty cool to see it in action.
So Michael, the part that like really fascinates me is the data collection stuff and being able to actually like measure all of this stuff. It's so cool that you've got all these different sensors in different places, different kinds of sensors. That's something I didn't catch when we first spoke about this, is that you're measuring both temperature and flow at different parts of the system. So it'd be super cool to see what you're using to collect that information and how you're collecting it. If you can show us something like that, that'd be awesome.
Yeah. Cool. Yeah. Like I said, I'm using Home Assistant. Now, I don't want to go too deep into the setup because we actually plan a whole video about how to set up Home Assistant, but basically, yes. So Home Assistant is a tool that is not made for that specific usage. It's an open source system that allows you to manage your whole home, connect all kinds of sensors. And the cool thing is, as we're all about KYC, it's running on your own computer. It's not connected to the cloud unless you want to, stuff like that. And so you can see all the different sensors that I have here. So it's quite a lot of different sensors, different temperatures. But what is really cool, that Home Assistant actually has an integration into Grafana. Grafana is a standard open source charting system that allows you to look at data over time in graphs. And so that's what I'm using. So I can shortly show you like what we're seeing here. So first of all, this is the yellow, is the hot water flow. So that was the water that we used.
Is this from now?
That's now. That's just now. Yeah. So that's 20 minutes ago.
Fantastic.
So this was actually the water that we created. In total, we used 11 liters of hot water that came out of it. And so you see that's where it started and then when it dropped. So that's while we were doing the stuff. At the same time, I can now show the miner power. So you see that the miner didn't start at the very beginning. It actually ramped up right afterwards. So it actually was full power when we stopped the water. So you see there is some delay in there. It's not an immediate thing, but you see that the water, the miner went up and it went to 1.6 kilowatt hours or kilowatts right now that it's using still, and it doesn't stop yet. So that's now, it's still running. The other thing we can see is the bit cool temperature. So that's the temperature of the bit cool before, during, and after. So before, you remember the bit cool was at 143 Fahrenheit. That was just the temperature from the last time. And then as soon as the water came, the cold water comes in, because it goes through the plate exchanger, the temperature of the bit cool drops massively. Like it goes down to 119 Fahrenheit and then slowly creeped up again at the same time as well. And it's already now at 141 degrees again. We can also see the temperature of the thermostat. So that's a lower thermostat temperature. You can see it was before we started, it was at 129 Fahrenheit, and it actually dropped quite massively to 77 Fahrenheit. So the water at the bottom was super cold, because my water right now, like outside, it's maybe like 80 degrees air temperature. So the water that comes in, I actually don't have a sensor on that yet. That's one thing that I still want to do, to have a sensor on the cold water that comes in, how cold or warm it is. But yeah, no, the temperature dropped quite massively. So that's the lower one. But if you actually look at the upper one, you see the upper one was not touched up at all. That's the cool system about the water heater, that there's the cold water gets dispersed at the bottom, and the top water actually was staying at a 130 Fahrenheit all the time. We can then look at the water that actually came out of the system. So you see the water that came out was 135 Fahrenheit. So that's what the water, so that you would actually have at the shower. That was that. And then we also see the water loop. So the water loop wasn't running, of course, at the beginning. So that's why it's just 100 Fahrenheit. That's just room temperature. And then now it actually, while it is running, the water loop, so the water that gets pulled out from the bottom and gets put back in, is now slowly going up. Yeah, and that's basically the whole system. And if we look at like 7 days of the whole system, this is then how this looks like. So you basically have, every time we used water, you see this all randomness throughout the day, and you see every time that the miner was running a little bit. So you can see it's totally also running sometimes without actually water being used. That's just because the water in the water tank gets colder, because over time it will lose its temperature. It's very good insulated. So you see that there, like sometimes here, it was just running for for a couple of minutes just to heat up the water again. But yeah, so you can see all kind of data, and that's how I can now actually compare the usage of the regular water heater with the miner water heater. And what I know so far, I'm still exactly working on it, because the fun problem is now I actually need to run the system without the miner for at least a week or two. So I need to enable the normal electrical heater again. And I don't want to do that because I'm not going to mine anything. So I'm not incentivized anymore to do that, but I'm going to do this. But I have a couple of days of data, and comparing them, we are looking at like maybe 3 to maybe 5% more energy usage of the water heater, Bitcoin water heater, compared to the normal electrical water heater. And the reason for that is just because, well, A, we have to heat up all the bit cool. That's obviously an additional mass that needs to be heated up. Now this stays warm because it's all insulated, but it's still additional stuff. Then you have the pumps, they run sometimes. So they create energy, and they also get hot in the end with that, but they also use a little bit of energy. So you have a little bit of loss there, but it's definitely way below 10%, hopefully even below 5%. That means in the end, the energy that this system uses compared to my normal water heater is 5% more, but it generates Bitcoin. So if you compare that, it's way worth doing that, because the Bitcoin is definitely more worth than 5% of what the water heater uses. And for the fact that I'm, of course, hodling it, it's going to be more worth in the future anyway. So no problem at all.
All right. So, I'm the type of guy. You're painting out. You've showed us all this, and you're taking us on this journey. And so, imagination, creativity going wild. You're like, wow, what's okay? So what we know right now is that you built the system. It's not always running.
Correct.
So that's actually an opportunity cost, right? So what's next on the horizon for your plans? What other uses can you see? How can we get that miner running full time or more and have other benefits in the house? What other use cases do you have in mind?
Yes. Yeah, so you bring up a good point, which is about it's not running all the time. So my miner, the S9, they would be horrible and not profitable if you would run them just for mining. In my case, because I don't care, because I would spend the energy anyway, I still make a bit of Bitcoin. But people ask me sometimes, like, could I use a more efficient miner? Like, I use an S9. There are S19s out there that will be profitable just for the electricity. The problem is, though, because they don't run all the time, it actually doesn't make sense to use a very efficient miner, because the upfront, the capex cost is quite high. Right now, I pay $200. An S19 has a capex of $3,000, $4,000, $5,000, $6,000. So you need to run this a long time until you cover the actual initial cost of your system. So I don't suggest to actually use very efficient miners unless you can run the miners 24/7. So coming back to your question, yes, what else could there be? Well, in the end, anything that is heated up could be replaced by that system. So if you saw before in my video, there's actually a whole left section that we didn't talk about. That's the whole heating system of my house. So my house, being quite an old house, is heated by normal radiators and baseboards. And what this actually is, it's hot water that gets heated up by an oil furnace. So we burn dead dinosaurs to heat up the water that then gets circulated in the house. But if you look at like an forced air heating system, so that's like that connects to your normal AC, it's again hot water in some cases that gets heated up and run through. So my plan is, as winter is coming again, my plan is to actually add a couple of more miners in there and use the BitCool to pump or to plumb it into the house water system, have a plate exchanger, a second one as well, that then heats up the water that gets circulated through the house. And basically my hope is to use no single drop of oil in the winter to basically heat the house with the miners as well. Now, this is most probably also not going to run it for 24/7 because we don't want a sauna in our house.
Sure,
well, we
sure.
could. But then, I mean, yeah, there's maybe a pool. We don't have one, but I know people have pools that they want to heat them.
Hot
That's
tub?
hot tubs, yes. You could boil the oceans if you want. No, don't do that part. But no, it's really like anything that uses heat. I've talked to people that say, well, I could connect this to the neighbor. Like you just plumb a hot water pipe to your neighbor and you heat their water as well. Like there's a lot of different ways how to use hot air. Maybe even the possibility to actually create cool. So it is technically possible to convert hot water into cold water as well. It's more used in industrial like systems, like data centers, for example, where you have a lot of waste heat. What we have to understand today, houses usually, like houses we live in, usually don't generate a lot of waste heat. The heat that is generated is all actively generated to be used directly, like in a house heating system, water heating system, whatever. But usually you don't have a lot of waste heat. Now, suddenly with the miners, we do have waste heat. And so there are physical processes, it's called absorption chilling, which can convert hot water into cold water. So maybe next summer, I might even figure out a way how to create cold water, which you can pipe into the AC system of the house and then cool the house. So in the end, you would use the miner for heating the water, heating the house, heating the pool, heating the hot tub, and cooling the house as well. So that, of course, would be like the end goal, that you can rip out all the other pieces that use electricity and you just have a miner farm in your house that runs your whole system. Yeah, that would be my end goal.
Yeah.
Give me a couple of months, but really,
All right. Let's say the end game without any,
yes,
with no trademark or copyright infringement or anything.
correct. But I mean, of course, like if we spin this further, like if we look outside of home systems, like now let's think about a hotel, think about a hospital, think about a school, like the amount of hot water they use, this is magnitudes higher than what we usually use for a house. And there you could totally run more efficient miners for 24/7. Even if you go like big apartment buildings and stuff like that, a lot of times they have central water heating systems. So that, of course, would totally work as well. And I think there, then you could build even cooler systems. So
we've got in the office that I'm in here, we share, there's a communal space and there's a water heater literally for coffee and that sort of thing, like right there. And that was a perfect example. Yeah. You could totally have a system that just heats water for coffee in shared office spaces and stuff like that.
Yes.
Totally.
The only thing we have to understand though is that right now with that system, you can get water to like 60 degrees Celsius, 140 Fahrenheit.
Good point.
I actually did the test once how high I can get the water, and it then gets really iffy with the miner shutting off suddenly and stuff like that. So you could maybe get to 70, 180 degrees Fahrenheit. You cannot get the water to boiling with the miner itself. There is, though, if we talk about physics again, there is heat pumps that can then do more. So you could actually use the miner to preheat the water to 70 degrees, let's say, or 60, and then use a heat pump to get the water to then the 100 degrees that you need for cooking or whatever. So that's possible. It will then just need another system to actually get the water hotter than the 60 degrees Celsius, 140 Fahrenheit, that you can get it with such a minor system. Yeah, so a lot of possibilities. I don't think we're just getting started here. Like I said, we have planned already to create a full video. It's probably going to be more like a live stream of a whole day where we're going to build such a whole system. So I want to start with just a water heater as you see it in every house with the whole system up and running. So that's the end goal. And that's what we're going to work on. Because like I said in the beginning, my goal is that everybody that has a little bit of knowledge is not afraid of plumbing and connecting a couple of pipes together to build such a system completely by themselves. That's the end goal. And yeah, that's what we're working on.
Very cool.
Yeah, that's great. It was really, I can't say thank you enough for walking us through that. That was just fascinating. I can't wait to work with you on some of these future videos. And, speaking of heat and heat exchangers, I don't know if it's just my laptop is getting too hot, but you might have noticed I had to cut the video. I've lost a lot of the last parts of the conversation, but I think this is a great high point to end today. Thanks so much for your time and again, enlightening and sharing this with us and putting it out there for the world.
Thank you.
Thanks a lot, guys.
See you all later.
Bye-bye.
Ciao.